Good morning and welcome to Sunday of week 4 of your Physics 5 a day, and today we're starting particle physics. So if we think about atoms to start with, you know that an atom is made of smaller particles called protons, neutrons and electrons, and you know that protons and neutrons are themselves made of smaller particles called quarks. But quarks are not made of smaller particles. You can't break up an up quark into smaller pieces, and so it's called a fundamental particle. And there are 12 fundamental particles that we know about and 12 fundamental antiparticles. Each particle has a matching antiparticle. And they fall into two families. You've got 6 in the quark family and 6 in the lepton family. In this video, we're just looking at the lepton family. So there's our familiar electron. We represent it like this, E with a little minus, and relative charge -1, relative mass about 1/2000. Now, as we said, every particle has an antiparticle, and the antiparticle has the opposite charge, but the same mass and the same everything else. So here is the antiparticle of the electron. We've got the opposite charge, but the same mass and same all other properties. And now the symbol is E plus because of the charge. But it's the only one. The anti-electron isn't known as the anti-electron. It's got its own name, so it's known as the positron. But then the next lepton you need to know about is the muon, and this is basically a heavy electron. And you can see that its antiparticle is just called an antimuon. And so there you go. Again, we've got the opposite charge and same mass. Now, each of these has a neutrino, a matching neutrino, and neutrinos are represented with, this is a Greek nu, it's like a Greek n lowercase for neutrino, and then the electron ones have got little e's there, and the muon ones have got little mu's there, and then the antiparticles have got bars on top to show that they're the antiparticles. But the easy thing about neutrinos is that none of them have got any charge and none of them have got any mass. And that's what makes them so difficult to detect, as you may have heard. So those are the leptons we need to know: our electron and positron, muon and antimuon, and the matching neutrinos. And last thing to say here is that muons are not stable. Muons decay into electrons.